friends. Thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we continue with our solution to special case under arithmetic progression and geometric progression. With us here is example 2. Let's look at how we can handle this. The question reads, a sequence of numbers first term, second term, third term, satisfy this relation 3n minus 2 all in bracket multiplied by the time n plus 1 equal 3n plus 1 multiplied by the time as given as un for all positive integers n. So n are all positive integers. Positive integers are 1, 2, 3, 4, 5 in that order. Given that the first term is 1, we are asked to find the third term as well as the fourth term. Roman numerals 2, an expression for the nth term, which is this term now, u. Then Roman numerals 3, the sum of the first n terms of the sequence. So let's look at how we can solve this. First thing to do, let's write down the solution to Roman numerals 1. The relation that was given is 3n minus 2 multiplied by the time n plus 1 equal 3n plus 1 multiplied by the time n. So we are told that the first term is 1 and the condition here is all positive integers. Okay, so since we know first term as 1, when n is 1, we substitute when n is 1 into this relation. So when n is 1, what are we going to have? When n is 1, we'll have 3 times 1 is 3 minus 2, that's 1, multiplied by u, that's 1 plus 1 will be equals to 3 times 1 is 3 plus 1, that's 4, multiplied by u1. That's the first term now. The first term here is 1, so we can substitute this first term as 1. So this will be the second term now will be equals to 4 times 1. And that will be the second term now is nothing but 4. First term is 1, second term is 4. Okay, but we are looking for the third term and the fourth term respectively. When n is 2, what are we going to have? Let's substitute again. It will be 3 times 2, which is 6. 6 minus 2 is 4. We'll have 4. The term 2 plus 1 now will be equals to 3 times 2, that's n now is 2. 3 times 2 is 6 plus 1, that's 7. Multiplied by u, that's 2, that's the second term. So this will be 4 multiplied by the third term will be equals to 7 times the second term is nothing but 4. So in place of this second term, we can replace 4. Okay, clearly here to find the third term, we can divide the both sides by 4. So that the third term now will be equals to this 4 will divide this 7. The third term is what? 7. Let me take it up here so that we can see it clearly. The third term is 7. Let me write it here. The third term is 7. To find the fourth term, when n is 3, what are we going to have? When n is 3, we still use this relation. When n is 3, what are we going to have? Let me remove this. Let's substitute. It will be 3 times, because 3 times n, since n is 3 now, it will be 3 times 3, which is 9 minus 2, that's 7. That will be 7 multiplied by the time 3 plus 1, that's 4. Will be equals to 3 times 4, 3 times 3 rather, that's 9 plus 1, that's 10. That will be 10 multiplied by the term 3, which is the third term. And the third term is nothing but 7. So it will be 7 multiplied by the fourth term will be equals to 10 times the third term, which is 7 now. Can divide both sides at this point by 7. So if we divide both sides by 7, what are we going to get? This will divide this will divide it. The fourth term now is nothing but 10. So let me clean here. The fourth term is nothing but what? It's nothing but uh, the fourth term is nothing but 10. So from here, we are through with Roman numerals 1. The next question will say an expression for the nth term. So let's rearrange this. The first term is 1, and the second term is, what will be our second term? Since the third term is 7, what will be our second term? Okay. From the question, the second term is given as 4. The second term is 4. We have found the second term as 4. Then the third term as 7. Then the fourth term as 10. Let's look at the behavior of this sequence. Is it geometric progression or arithmetic progression? From 1 to 4, from 4 to 7, from 7 to 10 is increasing by 3. The common difference is 3. This is what? This is arithmetic progression. So from here, we know that our first term is 1. The common difference is what? The common difference is 4 minus 1, which is 3. So let's get the nth term now. The nth term now, we can use the nth term of AP, which is n minus 1 multiplied by the common difference d. Okay, so let's substitute to see what we have. The nth term now will be equals to, first term is 1 plus n minus 1 multiplied by the common difference 3. So the the nth term now will be equals to 1 plus 3 times n, that's 3n minus 3. The nth term now will be 3n minus 1 minus 3. Of course, it will be minus 2. So the nth term is nothing but 3n minus 2. This is our nth term. Very important. So we are asked to find an expression for the nth term. That's this now. So this will be the expression. Okay? So we are through with Roman numerals 2. Roman numerals 3, the sum of the first n terms of the sequence. So let's move here to solve Roman numerals 3. Solution to Roman numerals 3 now. Let the sum be, let the sum of the first, let the sum of the first n terms be this sum. Let it be u plus 1, that the first term plus the second term plus the third term up to the nth term. Very important. Up to the nth term. Okay? Let's work on this to see what we'll get. Very important. Okay? Let's substitute. We know our first term, we know our second term, and we know our third term, respectively. So we are asked to find the sum. Let the sum be this. First term is 1, then second term is what? Second term is 4, third term is 7, fourth term is 3, in that order. But we are asked to find the sum of the nth term. Okay, sum of GP is n divided by 2 into 2a plus n minus 1 multiplied by the common difference. So sum now will be equals to n divided by 2 in terms of n now. We are asked to find the sum in terms of n. So first term here is 1, that will be 2 times 1, which is 2 plus n minus 1 multiplied by the common difference 3. So let's simplify this. Whatever we have will be the sum of the first n term. Sum of the first n term. Okay? So sum now of the first n term will be n divided by 2 into 2 plus, let's distribute this 3 over this. 3 times n is 3n. 3 times minus 1 is minus 3. Okay? So we have a bracket like this. Finally, let's simplify that further. I hope we are together. The sum of the first n term now will be, sum will be n divided by 2, bracket open. We have 3n, then we'll now say 2 minus 3, that's minus 1. So this will be the sum of the first n terms. We can leave it like this. n divided by 2, bracket open, 3n minus 1. We are asked to find the sum of the first n times. So the sum of the first n times will be this. So this is the solution to this question. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. See you in my next video.